The second fundamental theorem of integral calculus. A function f is bounded and integrable on closed interval a comma b, and there exists a function capital F such that capital F dash equal to small f on closed interval a comma b, then integration of f equal to f of b minus f of a. We prove this. What is a given? It is a given that f is bounded and integrable on closed interval a comma b. Therefore, for epsilon greater than 0, there exists a partition P a equal to x0, x1 up to xn equal to b with norm less than delta, such that the according to the definition of Riemann sum, f of ti into delta xi, I is equal to 1 to n minus integration of f between the limit a to b is less than epsilon, where for each choice of points ti in delta xi, this sum is less than epsilon. We can write it as limit of this summation of f of ti into delta xi, I is equal to 1 to n, where this mu of p tends to 0 is equal to integration f dx between the limit a to b. What are the points tr? This is depending on our choice. Now we know that we choose this point, we choose ti in delta xi such that such a manner that f of xi minus f of xi minus 1 divided by xi minus 1 equal to f dash of ti by, this is by Lagrange's mean value theorem. This is by Lagrange's mean value theorem. So we choose this mean value theorem. We choose this point ti in a such way that this condition of Lagrange's mean value theorem is satisfied, that is f of xi minus f of xi minus 1, xi minus 1 equal to f dash of ti. What is this? This is nothing but delta xi. Okay, so we write this as f of xi minus capital F of xi minus 1 capital F dash of ti into delta xi. Okay, what is a capital F? Capital F equal to small f. So this is equal to f of ti into delta xi. So this implies that if we take the summation of f of ti into delta xi, I is equal to 1 to n equal to summation of capital F of xi minus capital F of xi minus 1, I is equal to 1 to n. Okay, this is nothing but capital F of xi, f of x1 minus f of x0 plus f of x2 minus f of x1 plus f of xn minus f of xn minus 1. Now here x1 get cancel, similarly x2 get cancel, and we have with the value only f of xn minus x0, that is we have this value summation of f of ti into delta xi, I is equal to 1 to n equal to f of xn minus f of x0, but f of xn is f of b minus f of a. Okay, now if we take the limit of this summation f of ti into delta xi, where mu of p tends to 0, but this is the constant value, so it remain unchanged, and we have with f of b minus f of a. Okay, so this is what, this is a integration, and hence integration of f between the limit a to b equal to f of b minus f of a. This proves the theorem.